Hello and welcome guys. Now in this video we will be looking at linear regression assumption, all the assumption that linear regression takes. So basically linear regression is a statistical method used for model the relationship between a dependent variable and one or more independent variable. By how? By fitting a linear equation to the observed data. So there are several assumptions underlying linear regression, and these assumptions are important for validity and interpretability of regression result. And why this is important? This is important because they help ensure that the result of linear regression analysis are valid and reliable. Okay, so violation of this assumption can lead to biased and inefficient parameter estimate, incorrect inferences, and unreliable predictions. Therefore, it is essential to assess these assumptions while performing linear regression, and if necessary, take steps to address any violations. Okay, so we'll look at one by one. So first is linearity. So the relationship between the independent variable and the dependent variable should be linear is the very first assumption of linear regression. This means that the change in the dependent variable is proportional to change in independent variable. For example, in simple linear regression model with one independent variable, the relationship between two variables should be linear. Okay, so you remember the formula, right? Y equal to mx plus b. So I mean this relationship between the two variables should be linear. This is what it says. Next is independence. So what independence says? The observation should be independent of each other. This means that the value of one observation should not be influenced by value of another observation. Okay, so I mean you can look at this images. This is how it should look like. This is how it shouldn't look like. Okay, so for example, if you are studying relationship between age, income, so the income of one person shouldn't be influenced by income of another person. So that is what independence mean. Then we have homoscedasticity. Okay, so the variance of the error should be constant across all the level of independent variables. So this means that the spread of residuals, that is the difference between actual and predicted value, should be roughly the same across all the level of independent variable. For example, if you are studying the relationship between age and income, so the spread of residuals should be roughly same across all the ages that you can see here. I mean the difference is not much. I mean the spread is not very diverse. You can see on this graph the spread is very diverse. So that's why this is not following. Yeah, this is violating actually. Okay, so make sure this look our graph should look like this. Then we have normality. Okay, so the normality says the error should be normally distributed. This means that I mean the distribution of residuals should be bell shaped. Okay, so with most of the residual should be near to 0 and fewer residual at the tail of the distribution. What I mean by that is, so bell shape look like this. Okay, like a normal distribution, not like this. Okay, let me remove it. So our bell shape look like this. Okay, so most of the error should be here, most of the error should be here only. Okay, near to 0. So this is what normality says. Now next we have is no multicollinearity. Okay, so what it says, so there should be no perfect near perfect linear relationship between the independent variables. This means that the independent variable should be independent of each other. For example, if you are studying the relationship between age, income, education, and so age and income should not be perfectly correlated with each other, like one on one. Okay, the correlation is like 100%, 100%. It shouldn't be like that. Okay, so you need to make sure that is the case. Okay, so the closing word will be like, so the linear regression is a statistical technique used for modeling dependent variable and one or more independent variable. So I mean obviously the goal is to find the best fitted line which will where the relationship between the variable that minimizes the difference between observed value and the predicted value. So the least square method is a specific way of finding the best fit line or curve in linear regression by minimizing the sum of square differences between the observed value and the predicted value. So in mathematical term, it was used to estimate the value of regression coefficients such as beta 0 beta 1 in simple linear regression case that minimizes the sum of squared error. In other words, linear regression is a broader concept that include various type of regression model, while the least square method is a specific technique used to estimate the parameter of linear regression model. To sum up, the least square method is a technique used to find the best fitted line or curve, while the linear regression is more general concept that include many different techniques and model for analyzing the relationship between the variables. So that is what our assumptions are. Now in the next video we will be implementing all this assumption and see whether we are getting such a balanced graph or not. Okay, so that's all for today. See you in the next video.